On this week's Carrier Wrap, we speak with Signal's research group for perhaps some controversial commentary on the current pace of 5G technology developments. Well, thanks everyone for joining us on this week's Carrier Wrap. I am your host, Dan Meyer, Editor-in-Chief at RCR Wireless News. And this week we are lucky to be joined by Michael Thelander, who's the president and founder of Signal's research group, to talk a bit about the world of 5G, I guess. Hey, Michael, thanks for joining us this week. We appreciate it.
Good afternoon, Dan.
All right. Well, maybe start off with, I guess in the telecom space, it's hard to go anywhere or talk to anybody without at least some part of the conversation turning to 5G. Whatever that means to people, but it does seem like that this next network evolution is at least upon us in terms of people talking about it a lot. I know 3GPP is working on it as well. You yourself have been putting out lots of nice reports about kind of what's happening in the process. Obviously, you've been attending a lot of the events as well. So maybe we can start off with a little bit just your general overall view of maybe where we are in terms of this movement towards 5G. I mean, I know we're still early, but maybe your view and kind of how we've progressed over the past month, 6 to 12 months, and kind of where we are today in terms of that evolution.
Sure. So I guess just to start off, I really hate the term 5G and 4G. And I finally acquiesced, and I use the term 5G because saying next generation radio air interface becomes very problematic. When you talk about 4G, so to speak, I always say that I've never written the term 4G because it's so used and abused in the industry. So what does somebody mean? Is it HSPA plus? Is it dual carrier? Is it LTE advanced, et cetera? So I like to talk more about the actual feature sets. But that being said, I do use the term 5G because I don't like typing anything else. I would note that actually, interestingly enough, at the last 3GPP standardization meeting, I think the people that attend also faced the same issue whereby they didn't like using the term 5G, and so they're not sure what to call it, and they don't like writing something that's very long. So actually they're now calling it NR for new radio. Mm-hmm. And so I've kind of started using that term as well. The problem there is that it's not just an air interface. And I think the whole standardization effort of IMT 2020 or 5G, it's really about other aspects beyond the radio access network, and we'll probably get to that in a little bit. So with all of that as a backdrop, where are we in terms of NR or 5G? So I've been going to the 3GPP standardization meetings really going back to September of last year. And that's when they held their first kind of workshop on what is 5G going to be. And so, prior to that, you had the NGMN put out kind of their view, but really from a standardization perspective, not much had been done. Mm-hmm. And so everything about 5G in terms of what's going on in the standardization meeting, it never even started until September of last year. And ever since then, obviously the various working groups have been meeting, but it's still in the very, very, very early days of the standardization process. So to kind of put things into perspective, they're still defining, or I should say, we're still defining the use cases. So what are the requirements for 5G? What are the use cases? How's 5G going to be used? There's not an agreement there even to that regard. And the second thing is, once you define the use case, what are the requirements for that use case? Do you need 1 millisecond latency? Do you need a gigabit per second data rate? That's still being worked out. And then beyond that, the next best thing is, okay, so you've defined the use cases, you've defined the requirements. Now in the standardization body, when you're trying to define something that doesn't exist, you can't go out and test it. So you do modeling work, and you try to evaluate how will the various options for the air interface, how will they actually work in a real network, and you do that based upon modeling. Well, so there's now a lot of work being done to define kind of the modeling assumptions. Mm-hmm. And so that's kind of wrapping up pretty much at this point. And then at that point, 3GPP can go out and actually evaluate the various proposals, the various air interfaces, and the protocols being suggested, and actually model how they behave under various network conditions using the higher frequency bands, where, until a couple of years ago, nobody ever anticipated using those frequency bands as the actual air interface.
Yeah. I mean, definitely. I mean, like you said, it is an interesting dynamic right now, because it did seem like with the initial LTE rollouts, which, I hate using the 4G, 5G terms because that's a whole different story. But it did seem like even with those initial rollouts, consumer usage of broadband was still so limited to an extent that there wasn't this big idea of, hey, we're going to use mobile broadband for everything. And it does seem like nowadays, since everybody's so used to mobile broadband services, that it does seem like with this move towards NR, which I like that term better than 5G, that it is kind of being just assumed that's going to be in everything. Every vertical market is going to have some sort of radio mobile broadband component to it. And it's an interesting thing that it is kind of part of the process is trying to figure out how can we use this in every situation, every enterprise, every market out there going forward. That just seems like such a huge task to even try to accomplish. It's like it's just adding more weight to what is already a weighty situation as it is.
Yeah, it's interesting. You can go back and you can look at the initial kind of the requirements documents for both 3G, UMTS, as well as LTE, and you look at kind of what 3GPP was saying in terms of these are the use cases. And there was basically one use case, and that was mobile broadband. And it said this network must deliver so many kilobits per second or so many megabits per second in an efficient manner in the downlink and the uplink under these conditions. And that was it. It's a very short document. And I think with LTE, there was some expectation around energy efficiency and IPR, but that was pretty much it. And now you look at what's happening within 3GPP, and there's something like 75 or so various use cases, of which only a very small fraction involve mobile broadband. Mm-hmm. You have all these various vertical markets. You have vehicle to vehicle. You have biomedicine. You have industrial automation. You have robotics. You have flying drones. You've got all kinds of crazy things being thrown in there that involve vertical markets that have nothing to do with the wireless industry. And so now you've got a bunch of operators and vendors trying to figure out what the medical industry needs or what the industrial industry needs for their parameters. On top of that, it's unclear to me in a lot of cases whether or not these various vertical markets actually want a interface. It's like if Comcast calls you up or AT&T or pick your service provider and they try to sell you a new service. You kind of listen to the sales pitch. You say, yeah, okay, come back with a proposal. It doesn't mean you really want it. It just means that you're willing to kind of entertain the idea. And I think that's going to be the challenge for the industry, is to make sure that you define all of the appropriate use cases you want for the next generation radio. You make sure you've covered all the use cases. You don't include use cases that will never get deployed. And if you have a use case, you want to make sure that the requirements of the air interface meet the requirements, or the capabilities of the air interface meet the requirements of the use case. You don't want to over-design, but you also don't want to under-design. And so there's a lot of challenges there. It's not an easy task.
Yeah, and I think we'll definitely get back to maybe more of the air interface issue. But I guess on that topic, then I know in the report you put out recently, you talked a bit about maybe the use of software as perhaps one way to kind of maybe future-proof some of these releases that are coming up. But again, software can't necessarily solve everything, but it does seem like maybe a way to do it. I guess what's your view on that ability to do that? I mean, do you think it's a smart way to go? Could that at least, I know one of the quotes, and I told you this earlier, that I liked in your report was, doing everything in software may be future-proof, but it's not dummy-proof, is how you put it in the report. And again, I thought that made great sense. I mean, is that kind of, we can use software, we can't rely too heavily on software to kind of fix what might come down the road at some point?
Yeah, I mean, definitely. I mean, there's a lot of focus on making 5G NR future-proof.
Yeah. And
that's taking place in the core network. It's also taking place in the air interface. They have what's called a flexible frame structure.
Yeah.
So if you look at, LTE today, it's the same air interface delivering BitTorrent as it is a VoLTE call. And there's bearers there. You can do quality of service and those types of things, but that's really at a higher layer. And 5G is trying to address that in a more intelligent manner. And they are doing things to make it future-proof. But when you don't know what the future is, I mean, it's a little bit nebulous to say, oh, don't worry about it, we're future-proof. And I've had vendors kind of suggest that, not that they're just completely disregarding the future, but I think it's dangerous to put too much focus on the fact that just because we say it's future-proof doesn't mean that it is. And then the fact that, and it's true, I mean, definitely, the hardware today is much more software defined than it ever has been in the past. But there's certain things, especially in the air interface, that just require dedicated hardware. And I don't think anybody that's a big proponent of cloud-based IT infrastructure would disagree with that. And so I think we can't just, we can't just throw caution to the wind and do everything and say, oh, don't worry about it, it's all in software, because it's not. And even if you can fix something in software, that doesn't mean that's the most optimal solution.
Yeah, exactly. That's one issue. I know I've been covering a lot of the virtualization space on another show that I do, and that's been one of the issues. It's like, you can only take virtualization and software so far into a network, because obviously there are things that you have to have at the end of the day. That's hardware. But at the end of the day, it might not be more efficient to do it that way either. It might be more efficient to use hardware in some situations. So that's
and the other thing is, I mean, RF is also analog, and you've got antenna designs. You've got lots of things that have nothing to do with software.
Yeah.
And you can take a less than optimal solution and make it better with software, but it would be nice to start up with a hardware solution that's as optimal as possible.
Yeah, true. Yeah, it's nice to be able to have a dumb box that you can kind of put intelligence into, but if you can have a little bit smarter box, it's a little better that way to start with. That might be a better way to go. But yeah, good point there. Yeah. Well, I guess maybe now getting back to, the air interface issue, and this is kind of brought up with some other people I've talked to recently. But I mean, I guess as we look at whatever NR is going to be, I mean, is it going to be LTE based at this point? I mean, do we still expect the LTE air interface to still be the basis for 5G NR, whatever how we want to refer to what's going to be coming down the road? Do we expect LTE to still be the basis of that, or will it be a whole different air interface that will run side by side with whatever the LTE air interface is?
I would say it's correct to say that the next generation air interface will be based on OFDM.
Okay.
And I think that is universally agreed to. Now, OFDM can take on lots of different flavors, that will make it different than what's being done with LTE. And there's lots of various things being proposed to kind of, make it more enhanced. But ultimately, it's OFDM based. Now, the other question, and this is a question that I don't think there's an answer to at the moment, is, there's this concept of a unified air interface. So basically, ideally, whatever you have deployed at, 60, 70 gigahertz is the same thing you have deployed at 600 megahertz.
Mm-hmm.
Because you want that flexibility, that flexible frame structure, a flexible protocol, so that you're not deploying lots of different 5G radio systems. How that all works and whether or not it's going to work kind of remains to be seen. And that's one of the study items right now, is to figure out how flexible can we make the air interface so it kind of works across, anywhere from 600 megahertz to, 100 gigahertz, with channel bandwidths of a couple megahertz to hundreds of megahertz, and that's going to be a challenge, and so the flexibility of what's being proposed is definitely going to help there, but that's kind of to be determined, I guess.
Yeah, that's a good point. And actually, I was at an event recently, and someone there suggested that, when it comes to these higher frequency bands, maybe it makes sense for those to even maybe abandon the traditional cellular architecture where you have overlapping cells basically that can allow for handoff. Because if a lot of these IoT or whatever these machines are going to be, if a lot of them aren't moving, is there even a need to have cells that allow for handoff? I'm almost like a Wi-Fi model basically, where it's not really you can kind of focus more of your efforts on making a strong single cell and not have to worry about adjacent cells and whether it works between them. Should we even abandon kind of what's traditionally looked at as a cellular mobile type of connectivity and go with maybe more of a fixed architecture for some of these higher bands to make them, more efficient and not worry about, trying to drag that mobility thing up to those higher bands?
Yeah, well, I guess two examples there. So even today with LTE, if you look at narrowband LTE defined in Release 13, at least in Release 13, there's not a mobility element.
Yeah.
So to some extent, they're actually modifying what's being done in terms of mobility for a specific use case or deployment scenario involving narrowband IoT solutions, recognizing, to your point, that some devices aren't going to move.
Yeah.
Now that's probably a limitation. I think mobility will get introduced in the future, but that's an example to your point. The other thing is that when you start looking at, and this is the interesting thing, is when you start looking at the various use cases that are being defined and kind of the modeling assumptions and the requirements, you really do get a sense of what the architecture is going to look like. And to your point, definitely it's going to be a layered deployment scenario, especially involving these higher frequency bands. You're not going to have ubiquitous coverage. I mean, it's definitely going to be a hot zone-like scenario in a lot of cases, potentially leveraging the dual benefits of the lower frequencies for LTE, perhaps providing the control channels, all the information you need for scheduling or handoffs, et cetera, and then using the higher frequency bands more so in a very opportunistic way, whereby if you happen to be in range and you happen to have, your hands not blocking the phone, you get served a lot of data rate, high bandwidth. But in those cases where, you're doing an application or you're moving too fast, you continue to use the lower frequency bands and most likely LTE.
Yeah, it's an interesting point too. You said, yeah, I mean, if your hand is not blocking the phone, because it does seem like in those higher bands, I mean, even just a body can impact cell quality or quality of connection pretty dramatically. So that's going to be, again, trying to work those higher bands into an actual commercial type of service is going to be, it seems like it's going to be pretty tricky.
Yeah. I mean, the other interesting thing too, I don't want to be too negative on the higher bands. I mean, it is interesting. One of the nice things about the higher frequency bands, you can cram a lot more antennas into a mobile device and into a cell site. And the nice thing there with beamforming, you can compensate for a lot of things, both in terms of the actual propagation, so the actual coverage of a higher frequency band, once you start throwing in a 32 or a 64 array antenna, the actual coverage is actually pretty impressive compared to the lower frequencies. Likewise, just, simple blockage, it's still not going to solve, penetrating thick walls and being like Superman type of thing, but it is going to definitely compensate to a large extent for the higher frequencies by using a lot of antenna technologies that are being developed in parallel with the standardization process.
Yeah, and that's a good point you brought up in your report as well, is the fact that, yeah, once you get the higher bands, again, the antennas are much smaller, so you can, like you said, cram a bunch more into a device or into a site or whatever. So it's not so much of an issue as we see with the lower bands, traditional 700 megahertz, 600 megahertz, whatever we're looking at for cellular carriers. So that's a good point there. Another thing you brought up in the report too, and it wasn't a huge issue, but you kind of bring up the timing aspect when it comes to this move towards whatever 5G is going to be. And, you kind of cited, the fact that there are some sporting events coming up in a few nations that perhaps are going to maybe influence how some countries view these technologies. And I think we saw in the past, when China had their Olympics back in 2008, they were really pushing TDS, CDMA out there as being a big, whatever their 4G was going to be, or their 3G technology. So it does seem like these sporting events do have an impact a bit, because countries do want to show off what they can do. Again, we got some events coming up in Korea and Japan and in Russia going ahead too. So it seems like those could be, at some point, you don't expect a big impact, but it will kind of shape how some of these countries at least view their speed and their movement towards these next generation of services.
Yeah, I think the biggest challenge there, so I think everybody across the world agrees to what 5G should be. And there's three basic use cases. There's enhanced mobile broadband, there's machine type communications, and then there's also kind of the ultra reliability, very low latency applications. And I kind of define, everybody agrees those are the top three priorities. The question is, how do you prioritize those priorities? Yeah. And if you look at the Asian markets, so the Koreans, the Japanese, to a lesser extent, Russia, they really want to have enhanced mobile broadband. And they think that LTE will suffice, for machine type communications well into the next decade. Mm-hmm. Now you look at all of the operators in Europe, and it's the exact opposite. You know, they don't really care about enhanced mobile broadband. You know, because for them, it's other use cases to really drive kind of the growth in the economy. And so within the standardization process, you have to pick your battles, and you have to decide, okay, I want to do all these things. Which ones do I do first? And so that's one of the biggest challenges, and where the most battles are being fought now is where some operators want to prioritize certain features, or basically standardize certain things first at the expense of others. Everybody agrees, yes, we want these features and these capabilities. The question becomes, which gets done first? And then secondly, as you're perhaps prioritizing around enhanced mobile broadband, do you sacrifice the capabilities or the requirements of other use cases? For example, supporting millions of devices.
Yeah, that's a good point. I know one of the topics in that paper that your recent report was that first mover advantage in this, and it does seem like countries or operators that can kind of get out first, at least in their marketing or whatever they want to do, they're kind of getting out there first, at least can at some point drive or influence perhaps what 3GPP is going to be doing down the road in terms of standards. So it does seem like that's an important part, though, because these are operators who are fairly large operators who have a lot of clout and influence. It seems like in the standards bodies. And yeah, if they can get out there ahead of time, they can kind of steer where these things might go down the road, and to their advantage, obviously, if they can.
Yeah, I mean, you saw that happen with VoLTE, for example. So VoLTE roaming, there was kind of the GSMA blessed way of doing things, and then some of the operators that were first to market with doing VoLTE, well, instead of doing the local breakout, which is kind of what GSMA wanted to do, they wanted to backhaul everything back to the home network. And so they basically drove that initiative forward. And now I think most operators are going to adapt that approach. I think other examples, you look at LTE unlicensed, that was something that was originally done outside of the standards body, and ultimately it's now being included with LAA. I think those operators or companies, vendors that are kind of basically driving things outside of 3GPP, and I think to some extent, 3GPP is losing some of the influence it had in the past. And so if you're a big operator, not only a big operator, you want to be first to market, it's definitely in your advantage. If you're a big operator and you're not being actively involved, you're not out trialing things, you're not out pushing your vendors with, purchase orders to go out and build 5G, you're not going to have a lot of influence.
That kind of seems where we are today, because it does seem like over the past 6 months, maybe 6 months or so, it does seem like, at least domestically here in the U.S., if you're a U.S. operator and you have not announced a 5G trial with somebody in some Texas market, you are behind the times. I mean, you've got to do it, even if you don't really expect much out of it. You at least have to announce it, just to make sure that people realize, hey, we're serious about this and we want to be part of the conversation.
Yeah, and to be clear too, I mean, these so-called 5G trials, I mean, they're using a higher frequency band. They're probably radiating some flavor of OFDM. Yeah. But beyond that, there is absolutely no commonality with a standard, because there is no standard. Yeah. You can't say it's pre-standard because no protocols have been defined. I mean, there's nothing there. So it's a little bit lame on their part to do that. I understand why operators, at least in the marketing department, want to call it 5G. I can guarantee you the guys on the tech side, I mean, they're saying the word 5G trials, and biting their tongue at the same time. They just absolutely hate those terms, but that's what the investors want to hear. So that's what they have to say.
Yeah, I mean, we saw that with 4G as well. I mean, obviously, some of the operators here in the U.S. were kind of not forced, but they had a reason to get LTE networks out there as fast as possible, and they definitely jumped on that 4G bandwagon for marketing purposes, obviously. And so, yeah, now we're stuck with the 4G term for everything. And again, it seems like 5G is the same way as well. Again, I do like your NR. I think that's a new way to go with this. I think that's kind of, we need to get some momentum behind the NR tag for where we're going to go. And maybe, a ground roots level here to kind of get some swell going here to kind of get behind that instead of 5G.
But it's probably going to change. They're probably going to change NR, because that was like a last minute decision. I was hoping they'd call it PDQ, kind of like pretty darn quick. Because you have LTE, which is kind of lame long-term evolution. You might as well call it PDQ.
That works too.
That was not accepted. So I guess we're stuck with NR for the moment.
Yeah, I think there's some trademark issues with PDQ. I think there's some convenience stores that have that, but we can always get around that if we need to. But no, and again, it does seem like that the operators who are getting out in front of this, though, at least initially, like you said, they're maybe not. I mean, they say they're gaining at least some experience with using these new technologies, whatever they are. But you're right; it does seem like it's more of a just kind of marketing ploy at this point, or at least again keeping the investors happy and make sure everybody thinks you're ahead of the game, at least in terms of just moving towards 5G. So
yeah, I mean, it's also important to know, like Verizon with their so-called trial. I mean, it's really a fixed wireless extension.
Yeah.
So I think people envision there's going to be an iPhone with 5G in it next year or this year. I mean, that's nowhere close to being the reality. It's basically radiating a signal at a higher frequency band and kind of seeing what happens. And I think the other thing to point out here too is that I know in case of some operators, their whole purpose for doing these trials is to kind of evaluate how 5G or pre-5G or frequencies behave, in these, or how a signal behaves in these higher frequency bands, take that information and then feed it back into the standards bodies to kind of maybe help influence decisions. The problem with that is that these decisions are happening today.
Mm-hmm.
There is definitely a rush, if you will, to define the next generation air interface, NR, 5G. And so one of the challenges is that, are we going too fast? Are we going too slow? And I'm not sure I know the answer. Definitely it's moving very quickly. And I think these activities taking place by cutting edge operators and vendors doing things outside of 3GPP is by and large good. Mm-hmm. I think there are some negatives as well. Those operators that aren't involved, don't have a say in the show. And then I also think there's the risk that if we start defining a standard when we start defining protocols when we don't have a channel model to model these things that everybody likes, giving the chance to go out and actually evaluate everything being proposed. A lot of decisions are happening. They're happening very quickly, good or bad, we'll see in the next several years.
Yeah, and that's a good point. You're right. In the report, you did bring up the fact that these operators might be trialing these things today, but like you said, these are decisions that are already being made. And so again, the value, the true value of these trials, a little more in question because it's hard to go back in time and try to then put your influence back into what's already kind of been decided upon. I mean, obviously, carriers want to try to do as much as they can, but yeah, it does seem like the true value of these trials is a little questionable at this point.
I think the other advantage is maybe long-term market planning. So you can not necessarily influence the technology, but you can get the sense of, okay, how do I actually go out and build a network?
Yeah.
How do I market it? What's all those other kind of little things that come into play? That becomes interesting as well, I think, for the operators, just to get a sense of kind of what's going on.
Yeah, true. And again, using the high band spectrum in a commercial environment for wireless communications is something that's never really been done before. And so, getting just it seems like some experience in that at least can at least help operators as they look at their at their build out plans, whether it's small cells or whatever it's going to be going forward. That's going to be at least give them some insight, I guess, into that part of it.
Yeah, I mean, it's also interesting, and it's fair to note too, especially with the U.S. operators, there is so much that they haven't done when it comes to LTE that's ridiculous. And so they talk about, oh, I'm going to 5G. Well, come on, let's look at all the feature sets that have been introduced, beyond release 8, release 10, that you get to commercialize or deploy widely in your network. There's a lot to be gained in terms of, higher data rates, increased spectral efficiency, better user experience, you name it, that they haven't done yet.
Yeah.
And so the nice thing about 5G is that it does allow you to tap in to some higher frequency bands. But if you're using 28 gig or whatnot, you're not going to have ubiquitous coverage. I'm not going to have coverage at my home. So if I have a poor user experience right now on my AT&T or Verizon or T-Mobile network, that's not going to change with 5G.
Yeah.
So if I go downtown San Francisco, oh wow, I got a gigabit per second. Oh, big whoopee! I go outside of the downtown area, and it falls off, and I drop a call. That's the fault of the network. That's the fault of LTE.
Yeah.
So they can do a lot there to really make things better, over the next decade.
Yeah, yeah. Even just getting into the carrier aggregation space, which I think is it's a little more common probably in some Asian countries, but here in the U.S. and even in Europe, that's just starting to be kind of rolled out today. And there's still really no devices. There's a few devices that really support it. So
Oh,
even just getting that
actually,
out
I'll disagree on that one. There's
there. Okay.
actually a lot of devices that support it. There's actually devices coming out now that support 4x4 MIMO.
Some of the Samsung devices, right?
What's that?
Samsung devices that are coming out doing that, right?
Well, I'm not sure I'm going to say, but
Okay.
there are devices out there that I've heard about. I'm not sure what's been announced publicly. Now, they support it in hardware, not necessarily in software. So it's not like they're commercial today. But you are correct. Carrier aggregation, at least from the infrastructure side, is not supported as widely as it could. Or if it is supported, they're doing it across 2 carriers versus 3. The standard actually supports up to 32 carriers. So you could get literally, I believe that the peak data rate on LTE defined today is 25 gigabits per second. Now, in the downlink and 12.5 in the uplink.
Mm-hmm.
Now, nobody has that much spectrum to get that high a data rate, but at least standards-wise, it's possible. So AT&T could take every single LTE carrier they have, add some more, combine it all into one basically logical data rate or one logical channel, give you gigabits per second of speed, and it's supported today by the standard. But they're not doing it. Now, obviously, I don't think the chipsets support it, and the infrastructure doesn't support it, but it's defined in the standard.
Yeah.
And so they could do a lot of things if they really wanted to offer a much better user experience without going to a 5G standard.
Yeah, I would guess though that the handset supporting that would just explode immediately from from heat generated by getting that kind of speed down to the device.
Well, but if it doesn't, it's going to do the same thing with the 5G as well. That doesn't change anything. I mean, obviously, there's a lot of processing power, additional memory that's required, to get to those really high data rates. But conversely, if you can burst a 1 gigabit per second speed to me, my radio can turn on and turn off all that much faster because I've downloaded my YouTube video in half a second versus 10 seconds or whatever the math is.
Yeah, that makes sense.
There's an advantage there. But my point still is that, definitely operators, regardless of who they are, could do a lot more to really improve their networks today without going to a 5G standard.
Yes, that makes sense. And again, that'll be our end message today then for operators is there's still more you can do with LTE. Obviously, 5G or whatever you want to call it is exciting from the marketing perspective, but and you got to work on it at least. But there still seems like there's so much still available with LTE today that if they wanted to, they could definitely do it. We'll see whether the marketing people let them do that, but we'll see how that all plays out, I guess.
Yep.
Very good. Well, hey, Michael, again, appreciate the insight. I think we could talk for another hour on this, but I'll save you from having to look at me for another hour. But I would recommend for those who are watching this here, definitely check out the Signals Research Group website. And again, the latest report you put out, kind of looking at where we are in terms of 5G. It's a great read, I think. I mean, some of
it's free.
And it's free. That's the best part about it, which is not, you can't say a lot about that for Signals Research Group. They charge you a lot of money. No, I'm just kidding. No, but this is free. It's great stuff. Again, Michael does a good job, and the group there does a great job of kind of putting stuff that's pretty technical into an easy to understand format, which is what I like about it. So that's why I do like to tout it. I don't like to tout a lot of things, but that's one thing I do like about your reports is it makes something complicated fairly easy to read, which is nice. So for us reporters out here, we definitely appreciate that at least. So, but I definitely recommend those who are watching to check it out and give it a read. But again, Michael, appreciate the time today. Thanks so much for the insight, and hopefully we'll talk again soon.
Thanks.
Well, thanks for watching this week's show, and make sure to check us out again next week when we are scheduled to speak with Dan Hayes from PwC about IoT opportunity and U.S. government policy.